So today we're going to be talking about the Fibonacci sequence. And it's going to be based on the video on YouTube called Fibonacci Mystery Number File. Okay. Just going to share the screen here. Excuse me. All right. So, first we're going to look at what is the Fibonacci sequence. Just to get you caught up on exactly what's going on here. Basically, the Fibonacci sequence is where you have numbers, and each number is the sum of the previous number. So we start with 0 and 1, and now we can do it. So if each number that follows next is the sum of two previous numbers, we have 0, we have the 0 plus the 1, which is a 2, then we have 1 plus the 2, which is a 3, and we have a 2 plus a 3, we get 5, and so on. That would be 8, this would be 13, 8 plus 13 would be 21, 13 plus 21 would be 34, 34 plus 21 would be 55, 55 plus 34 would be 89. So that's basically the sequence, and the sequence goes on forever. It just keeps going. Okay, so this sequence actually has great properties to it, and it's found in nature, all over nature. What this video specifically is going to speak on is how it works in music. So what was really cool in this video is he goes over the pattern that was used in music and why it happened. So let's see here. Okay. So looking at so what we're going to do is actually how we're going to turn it into music is we will divide by 7 and look at the remainder. So basically what that means is if we divide by 7, look at the remainder, then the numbers before, it gets bigger than 7 is going to be the same. But when it gets to 8, see, 8 here, that's going to be divided by 7, so remainder is going to be 1, so we put 1 here. And the divided by 13, we get a remainder of 6. And then, so divided by 21, we get 3, but remainder 0, so 0. 6, 6, 6, 6, 5, and so on. And what's really cool is if you continue in this, it'll actually start to repeat. So I'll even kind of go forward. 4, 2, 6, 1, and after the 1, it actually goes back to the same thing. 0, so dot, 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 like goes back to 0. So it actually repeats. It does the same thing here. And that's actually called a persona period. Persona period. And note here, any number that you pick that you're going to divide by and look at the remainder, it will be you always have a persona period, but you'll have a different amount of digits. So in this case, the digits were 16. Of 16, because the amount of numbers, the amount of digits you see here are 16. So the amount of numbers you see here are 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, should be 16. Let's see. Oh, I'm missing a 1 here. I see. Yeah, that was a little bit. So here we have an actual 1. Should have been 16. There we go. So yeah, 0 plus 1, I don't know how I messed that up. Okay, 0 plus 1 is equal to 1, and then, yeah, 1 plus 1 is equal to 2. Okay, so anyway, persona period is 16. Let's, for example, divide by 5. So let's give another example. Example, we're dividing by 5 and looking at remainder. Now, that's going to end up being, we have 0, 1, 1, 2, 3, 0, 3, 0, and then dot, 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 we go to 2, 2, 4, 1, and it repeats, and that's going to actually be 20 digits. So 20 digits in that persona period, and 16 digits in the first persona period. So notice that you get a persona period wherever you go. So what was really cool about this in the music, Fibonacci music, is that because it repeated, he could continue doing the same notes over and over, and it would sound like an actual piece. And that's all. Thank you for listening, and goodbye.